Think about how we've made things for, the last few thousand years. It's always been a bit like trying to get a single cookie out of a giant sheet of dough, but wasting away half the dough in the process. We find a tree, we chip away the not chair parts. We find a rock, and we bash off the not spear parts. We've always been subtractive, which is a nerdy way of saying we're really good at making messes to get to the good stuff. But back in the early 80s, an engineer named Chuck Huell had a thought. What if we stopped fighting with the raw materials and just started from scratch? He realized the way we made things was fundamentally broken, and his fix ended up changing how the physical world is built. Chuck's day job was a bit niche. He worked with UV lights to dry tough coatings on tabletops, essentially a super-powered nail salon for furniture. It was fine, but Chuck was a dreamer stuck in a nightmare of red tape. You see, back then, if an engineer had an idea for a new plastic part, they had to wait months. They had to send drawings to a tool and die maker who would carve a metal mold. If the design was off by even a millimeter, the mold was trash and the clock reset. Chuck grew tired of the waiting. He grew tired of the waste. He began to wonder, what if we didn't need the mold? What if the light I'm using to dry this table could be used to grow an object? Chuck didn't have a massive team or $1 billion grant. He had a small, cramped lab and his Friday night. His boss didn't really understand the vision, but he gave Chuck a corner of the shop to play with his UV experiments. Picture him there, late at night, the air smelling of chemicals and ozone. He had a vat of liquid photopolymer, a strange substance that stays liquid in the dark but turns into solid plastic the moment it's touched by ultraviolet light. One night in 1983, he called his wife, Annetta, and told her to come down to the lab. He was nervous. He lowered a platform into the liquid, just a fraction of a millimeter. A beam of light danced across the surface, tracing a single circle. He lowered it again, another circle. Layer by layer, the machine was growing something from the deep. When he finally cranked the handle to lift the platform out of the vat, there it was, a tiny blue eye wash cup. It was a humble object. To a passerby, it looked like a toy. But to Chuck, it was the first time in human history that a physical object had been summoned. He told his wife, "This is gonna take a long time to catch on, but it's gonna change everything."
The alchemy of the machine. So how does this magic actually happen? If you look at a 3D printer today, it looks like a high-tech microwave, but inside, it's performing a feat of digital alchemy. We take an object and run it through a slicer. It's basically a digital deli meat slicer that takes a 3D file and chops it into thousands of paper-thin 2D maps. When the printer starts, it is a master of patience. If it's a hobbyist printer, it's pushing a thin strand of plastic through a hot nozzle, much like a master baker piping frosting onto a cake. It draws the first map. Then, it moves up by the width of a human hair and draws the next. We are no longer limited by what a tool can reach. We are only limited by what we can imagine. To a traditional machine, a hollow ball with a lattice inside is impossible to make. But to a 3D printer, it's just another series of layers. If you think printing a plastic cup is magic, consider the highest stake manufacturing project in the universe: the human body. Every day, people wait on lists for organs. Every day, some of those people run out of time. But what if the shortage wasn't a biological limit, but a manufacturing one? Today, we are witnessing the rise of bioprinting. Instead of plastic filaments, these machines use bio-ink, a slurry of living cells and nutrient gels. Imagine a printer at the Wake Forest Institute for Regenerative Medicine or Stanford Engineering. It doesn't just lay down layers, it breathes life into them. We are already printing ears, skin grafts, and bone scaffolds that the body accepts as its own. We've even seen researchers successfully print a tiny, functional human heart, complete with blood vessels and chambers. It's small, and it's not ready for a chest yet, but it is proof that the unmakeable is becoming real. We are moving toward a world where a patient with kidney failure doesn't wait for a donor. Instead, doctors take a small sample of the patient's own cells, grow them in a lab, and print a new kidney. No organ rejection, no lifetime of immunosuppressants, just a perfect, personalized biological fit. A world rebuilt. Why do we need this? Why did Chuck Hull's invention become the spark for a new industrial revolution? Because we live in a world of standardized parts, but humans aren't standardized. Look at medicine. For decades, we tried to fit humans into boxes. If you needed a replacement joint, you got something off the shelf. A medium-sized titanium hip.
But you aren't a medium, you are you. Today, surgeons take a CT scan of your body, and within hours, they have a custom implant that fits your anatomy to the micron. We are even beginning to print with bio-ink, using a patient's own cells to grow ears, skin, and eventually, hearts. Beyond our bodies, look at our planet. Traditional manufacturing is a logistical nightmare. We make a part in one country, put it on a massive ship, and burn fossil fuels to move it across an ocean. 3D printing offers distributed manufacturing. You don't ship the object, you ship the file. You print what you need, where you need it, exactly when you need it, no waste, no massive carbon footprint, just the intelligence of the design manifesting in the local environment, the house in a weekend. While some printers are working at the microscopic level of cells, others have grown to the size of cranes. This is the concrete frontier. Think back to how we build houses today. It's slow, it's dangerous, and it's incredibly wasteful. We ship wood, bricks, and steel across continents, only to throw 30% of it into a dumpster at the end of the job. But in Austin, Texas, a company called Icon is changing the math. They use a massive gantry printer called Vulcan. It doesn't use wood, it uses a proprietary concrete mix that flows like toothpaste and sets like rock. This machine can print the walls of a 2,000 square foot home in under 48 hours. It doesn't need 100 workers, it needs a small crew and a digital file. But it's not just about speed, it's about empathy. They are using this tech to build communities for the chronically homeless and affordable housing in places like Mexico and India. In a world with a massive housing shortage, 3D printing is the only technology that can build fast enough, cheap enough, and sustainably enough to catch up. And if we can print a house in Texas, why stop there? NASA is already working on MMPact, a project to 3D print habitats on the moon. We won't ship bricks to space, we will ship the printer, and the moon will provide the ink. As we look at the towers of 3D printed concrete being raised for the homeless, or the rocket engines being printed by SpaceX and NASA, Chuck is still with us. He didn't become a household name like Edison or Tesla, but his fingerprints are on almost everything you touch. He gave us the freedom to fail. In the old world, a mistake cost $1 million and 3 months of time. In Chuck's world, a mistake costs 5 cents worth of plastic and an hour of your time. He moved the barrier of entry for being an inventor from the elite few to anyone with a laptop. He realized that the greatest resource on Earth isn't oil, gold, or steel. It's human ingenuity, the last layer. So, the next time you see a 3D printer whirring away in a library or a garage, don't just see a machine making a plastic toy. See a bridge between a thought and a thing. Hull started with a tiny blue cup, but he ended up handing us the keys to the physical world. He proved that we don't have to settle for what's off the shelf. We can imagine a better world, and then, one paper-thin layer at a time, we can simply grow it into existence. The question isn't what the machines can do anymore. The question is, now that the wall between your thoughts and the physical world has vanished, what are you gonna create?